Good day, class. In this video, we're going to discuss digit problem. So by the end of this lesson, your takeaway will be able to apply the concepts in algebra in solving digit problems. So this is the concept in analyzing a digit problem. But before anything else, before the analysis, please do note that uh, a number can either be a single digit, it could be a two digit or three, so on and so forth. But for our analysis for this video, we're going to focus on the two digit and three digit numbers. So let's start with the two digit numbers. Now we are going to represent the ones digit of a two digit number by the letter U, or this is also known as the units digit. Because if we're going to write a two digit number, let's say for example we have 41. So the number 1 right here is our ones digit because its position relative to say we have a decimal place here is at the ones place, whereas the number 4 is our tens digit, and we are going to denote this one by the letter T. Okay, this one is for the tens digit. Now if we are going to express 41 in terms of the variable U and T, we are going to use this expression 10T plus U. So the reason why we multiply 10 by T, because the place value of our tens digit is equal to 10. So if we're going to rewrite 41 in terms of this form, so that would be 10 times 4 plus 1. And we all know that that is 40 plus 1, or simply equals to 41. Okay, now this is how you are going to denote the original number, that is 10T plus U. Now in some digit problems, there are some conditions that are present in a problem, or that are stated in the problem. So we have here the reversed digit number. So if the number is reversed, of course the order of the digits in a number will also be changed. So if we're going to reverse that one, so our ones digit will be the tens digit, and then our tens digit will now be the ones digit. So that is why instead of T here, we used U. So you have, or we have 10U plus T. Now let's go back to our example 41. So if we're going to reverse 41, that would be 14. Now if we're going to implement this mathematical expression 10U plus T, again our units digit is 1, so we multiply it by 10, so it would be 10 times 1, and then plus our tens digit, which is 4. So that would be 10 plus 4, that is equal to 14. Okay, so use these expressions to represent the original number, and use this one for the reverse of the digit number. Now let's proceed to the uh, three digit number. So the expression used in representing the original number is 100H. So H is for the hundreds digit, So we multiply it by 100, by the word itself, 100. So 100H plus 10T plus U. Now if we're going to reverse that one, so instead of H, we will start at U, then the middle digit, its position does not change after the reverse, after reversing the digits. and then the H will be interchanged with the order of the U. Okay, so we're going to use these expressions in order to analyze a digit problem, because um, um, the other steps in, or the other solutions present in a digit problem is more on algebraic manipulations. Okay, let's start with this first problem, this first example. So the sum of the digits of a three-digit number is 14, the hundredths digit being 4 times the units digit. So if 594 is subtracted from the number, the order of the digits will be reversed. So the requirement of the problem is the number. So the number is 842. So how are we going to get 842? Now, if we have a digit problem, um, your technique in analyzing this one is that, again, make sure to identify how many digits are being um, perceived by the problem. So in this case, it is stated that we have a three-digit number. So for a three-digit number, it comprises of the hundreds digit, the tens digit, and the ones digit. So expect a three-digit number answer. Okay. Next is um, make sure to translate the verbal statement of each sentence in the problem into an equivalent mathematical statement or mathematical equation. So you need to translate per sentence if possible. Okay, so let's start with the first sentence. The first sentence states that the sum of the digits of a three-digit number is 14. So simply, we're going to add the three digits. So the hundreds digit is represented by, again, this is for sentence 1, is represented by H. Then we add it by the tens digit. So do not put 100 here because we are talking about the individual digit, not the value of the number. So H plus T plus U is equal to 14. Okay, so we have just translated the first sentence into its equivalent mathematical equation. So this would be our first equation. Next, let's proceed to the second sentence. So sentence number 2. So it states that the hundredths digit being 4 times the units digit. So the hundredths digit, which is represented by H, being 4 times. So being, this one is more like a linking verb. So in mathematical terms, that is equivalent to the equal sign, being 4 times the units digit. So that would be 4 times the units digit. So this will be our equation 2. Next, let's proceed to sentence number 3. Okay, it states that if 594 is subtracted from the number, the order of the digits will be reversed. Okay, so we have a value here that is equal to 594, and then we are going to subtract this one from the original number. So if it talks about the original number, it talks the value of the number as well. So therefore, in uh, in representing the value of the number, we're going to use the expression from the previous slide, in which we're going to multiply the place value of its digit. So we have the 100H plus 10t plus u. Okay, so this expression represents um the original number, and then from sentence 3 we're going to subtract this one by 594. So minus 594. uh, After the comma, it states that the order of the digits will be reversed. So instead of the h, uh, we're going to start the hundredth digit by u because of the word reverse. So that would be 100 u plus 10 t plus h. Again, this is the original number minus 594. The answer is the reverse of the original number. So for sentence 3, we need to simplify the equation. Okay, so we're going to combine like terms. Now we can transpose h to the left side and u also, and also t, and then we're going to isolate the constant to the right side. So 100h minus h, that would be 99h, and then we have 10t minus 10t, so this will be cancelled out because it will become 0 after transposing that one. Then for u, we have 100u here. If we're going to transpose that one, it will become negative. So u minus 100u, that would be minus 99u is equal to 594. Now, 99 here is common, so we can factor out 99. So we have 99 times h minus u is equal to 594. So divide both sides by 99. So you have h minus u is equal to, so 594 divided by 99, 4 divided by 99, that is equal to 6. Okay, that is equal to 6. Now this will be our equation 3. Now as you notice, in our equation 2, our h is equals to 4u. So we can substitute the expression of our h here in terms of u from our equation 2 to equation 3. So we have 4u minus u. Again, h is equals to 4u is equals to 6. So we have 3u is equals to 6. Divide both sides by 3. So we have u is equals to 2. Therefore, our units digit is equals to 2, which is the same with our answer. Next, we are going to use this value of u in order to solve for h in equation 2. So in equation 2, we have h is equal to 4u. So that is equal to 4 times 2. That is equal to 8. So therefore, our hundreds digit is equals to 8, which is equal to our final answer. Next, in equation 1, so we have h plus t plus u is equals to 14. So in equation 1, we are going to solve for t because we already have a value for our units digit and hundreds digit. So we have t is equals to 14. Now we're going to transpose h and u to the right side of the equation. So minus h and minus u. So this is 14 minus 8 minus 2. So that would be equal to 4. So therefore, our number is equal to 8 for the hundredths digit, then 4 for the tens digit, and then 2 for the units digit. Okay, so that would be all. Thank you for watching.